let's take a function f of x, which is x square, and see how the graph behaves when we multiply the x values by a factor, or rather change the x values and see how the graph behaves along the x direction, horizontally rather. So the function is now f of x is x square. So we are going to study f of a times x. We are going to multiply the value of x by a factor a. So the function x square would become ax the whole square. Now let's take two cases where a is greater than 1 and a lies between 0 and 1. Let's take the value of a to be 2 here for a greater than 1 and the x value to be 2. So this would become 2 times 2 whole square, which is 4 square, or 16 is going to be the value of the function when x equals 2. For the case a greater than 1. When a lies between 0 and 1, let's take the value of a to be 0.2. And so the function becomes 0.2 times 2 whole square, or zero point 0.4 square. This is 0.16. So we get two coordinates 2, 16 for the case a greater than 1 and 2, 0.16. Now let's look at them in the graph. Originally 2 square would be 4. Let's take this value of 2 here. Let's say 4. This is 2, 4. Now when a is greater than 1, for the same value of 2, we get 16. So 2, 16. Or we would see that if we study this for many points, the graph would horizontally get compressed or pushed in, we can say like that way, this quadratic graph. And if we take the case of a lying between 0 and 1, we get 2, 0.16, which means for the same value of 2, we get 2, 0.16 as the coordinate. So the graph gets pushed out or stretched horizontally. The same graph would become rather like that. It would get stretched horizontally. But please note, when we say it is stretched horizontally, I cannot say it is stretched by a factor zero point 0.2, because when we multiply something by zero point 0.2, it actually decreases. But since we are studying the horizontal direction here, if you measure and see, it would exactly get stretched by 1 by 0.2. The same applies for compression. We cannot say it gets compressed by a factor 2. When we multiply something by 2, it actually increases. But along the x direction, if you see the graph, it gets compressed by a factor of 1 by 2. So to summarize, if a is greater than 1, f of ax gets horizontally compressed by a factor 1 by a. If a is lying between, let's say, 0 and 1, f of ax gets horizontally stretched by a factor. A greater than 1, it's compressed horizontally. It is compressed horizontally. And if it is a lying between 0 and 1, it's stretched horizontally.